Hi there. Today we'll talk about expressing a complex number in the form r brackets cosine theta add I sine theta. If we look at a little sketch here, we have our radius r, the point P at the end here, and this being your x-axis, this your y-axis. So this is x and this is y. We have that x is equivalent to r cosine theta, theta being here, theta adjacent over hypotenuse is the cosine of theta, which is x over r, which gives us x equal to r cosine theta, and y is equivalent to r sine theta. Now if we have that x, which is equivalent to r cosine theta, and we have y is equivalent to r sine theta, we have the complex number x add yi equivalent to r cosine theta add I sine theta. And we can neatly write this as r, oops, I forgot the r here, r cosine theta add I sine theta. So all we need to do with a complex number is to determine r, the radius. We need to find the principal argument, and that will be theta, and then we write it in this form. Let's have a look at an example. So our complex number is 1 add I. We do a quick sketch here. That will lie somewhere in the first quadrant. We don't name these, we just leave it as x being the real and y being the imaginary axis. So 1 add I, to find r, we have 1 squared add 1 squared, take the square root of that, gives us root 2, and theta is equal to the argument of 1 add I, which is pi over 4. Remember, the argument is also tan inverse of, in this case, y over x. So therefore we can write that 1 add I is equal to root 2 brackets cosine pi over 4 add I sine pi over 4. Which we write as root 2 cosine pi over 4 brackets So there we have it. We have our complex number 1 add I, and we've expressed it in the form r, which is root 2 in this case, cosine theta, which is cosine pi over 4, add I sine theta, which is pi over 4. If you'd like to check this for Cartesian, you can actually just clear the brackets. So you can write for Cartesian, this is a form of a check. You have root 2 brackets root 2 over 2, and that's cosine pi over 4. Add root 2 over 2i, and this evaluates to 1 add I. So we're back to what we started with, the complex number 1 add I. Thanks for watching. I'm Alistair.